Welcome to the beautiful world of calculus. Calculus is a subject that helps us better understand the world we live in. It helps us understand weather. It helps us be able to make space shuttles to leave the Earth's atmosphere. Alright, calculus is an expansion of all the math you've used so far and put it into more of a real life scenario, and you'll see that come to play when you learn the subject. Now, where did calculus come from? Well, it was actually not that old. It was created in the late 1600s by two different guys, Newton and Leibniz. These two guys there's a conflict between these two guys as who actually invented it. Newton started working on it earlier, but Leibniz here published something first. Newton has been given the credit for inventing calculus, but a lot of people think Leibniz actually created it first. So there's an argument on who really made it first. Well, they all within a couple years that they both published their stuff. But Newton has some prior stuff known before Leibniz published his. So you choose who invented it. It's not a for sure fact of who. The notation we use today is Mr. Leibniz, but most people think of calculus and think of Newton. Newton is the guy who had the apple fall on his head, by the way, gravity. Anyways, why do we need calculus? Well, before calculus we had algebra, geometry, trig. They can only do so much. With calculus, broadens and opens up the world we live in, because we live in a world of change, and calculus is the mathematics of change. Calculus allows us to do roller coasters, allows us to build wonderful bridges and understand pressure and force and accelerations and speeds. It allows us to know pressures on make dams to keep water from breaking them. There are so many interesting things that calculus can do for us. Now, calculus, or before calculus, when we try to find slope at a point, we had to do approximates. We had to use or find 2 points to find slope at this point. Before calculus, if I wanted to find the area under this curve, I needed to make rectangles to find the area under the curve. Well, when you get into calculus, you will learn to find a slope at 1 point. You will learn to find the area under the curve by making these rectangles teeny, 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 tiny to the point that they have no width. Calculus allows you to do drastically new things. It's the mathematics of change. For instance, calculus allows you to find instantaneous speed, where before calculus you had to have average speed. Imagine a police officer on the side of the road trying to get the speed of someone driving by, for instance, this semi. He would have to find an average speed by marking 2 points. But with calculus, you can find instantaneous speed, like the radar gun idea, or your speedometer. It allows you to find instantaneous speeds. With energy, or how much energy it takes you to, say, push an object up a straight hill, well, you could find that without calculus. But with calculus, you could find how much energy it would take to go a constantly changing hill, a hill that constantly fluctuates, up and down, up and down. You could find how much energy is needed on a constantly changing hill. Change. That's what calculus lets us do. It allows us to find real life scenarios. It's all around us. Now, what does calculus look like? Well, calculus starts off with something called the limit. That is the basic building block that creates the two major components of calculus. The first one is called the derivative. This is a notation for it. And then from that, we then learn the integral, and this is a notation for that. All right. The derivative is about slopes at points. The integral is about area under curves, as you can see these. And limits, they are what created it and started it. Now, the derivatives. Well, a derivative, I mentioned earlier, helps you find the slope at a point. If I want to find the slope at this point on the curve, I can find it. I don't need 2 points to make the slope, I need 1. With the derivative, you could find maximum minimums of a graph like this. You could find these two values, find the highest and lowest, which in life, maxes and mins are actually really important, and you'll see that and learn that. Calculus allows you to sketch graphs like this, very detailed, and get all the important things of a graph. Before graphing calculators, it was so useful. With graphing calculators, it's still useful, but you can get a lot more done with a graphing calculator and dive deeper into it. So what is a derivative? A derivative is about rate of change. It's about the rate at which things are changing over time or other scenarios, but it's about rates. Now, the integral undoes the derivative. The derivative is slope, the integral undoes it. And what can an integral do? An integral can find area under curve. See this curve right here? You can find this blue area, this yellow area, and this blue area. You can find areas under curves, and that is very useful. You can find volume of a solid of revolution. That means if I take this solid, right here, this area, and revolve it around this x-axis, you get this solid shape. And it's kind of hard to visualize here, but you will learn how to find volumes of irregular shapes. So what is an integral does? It finds accumulation. It accumulates stuff. It finds areas under curves. It accumulates rates, accumulates whatever you want, but it's an accumulation method. Very useful. So, welcome to calculus. Wonderful subject. It's the mathematics of nature, like I said earlier. It's everywhere around us. It's such a useful subject. You don't even know how much things you take advantage of because of calculus. Calculus, it helps us understand electricity, motion, economics, money, finances, speed, acceleration, space. The list goes on and on. Because life is about change. The world changes. Time. Things aren't always constant. The subjects before calculus were about constant. Now it's about change. Enjoy the world of calculus. It's a beautiful subject, and good luck with it.